Hi students, a very pleasant and warm greetings to you all. Hope you are doing good. Last session we have started to learn about the mobile networks, right? In the chapter network examples and protocols, we have learned about mobile networks, and in this session we are going to see the generations of mobile networks like first generation, second generation, third generation, fourth generation, fifth generation, 1G, 2G, 3G, 4G, 5G, right? First, let's see what is first generation. First generation means in the year 1981, okay? 1G was launched in 1981, okay? During the initial periods and all, when you see this mobile networks used only analog transmission, right? This is launched by NMT launch, like Nordic Mobile Telephone Communication. We'll say this 1G as Nordic Mobile Telephone Communication, and that's what here they have given us NMT, right? At that time and all, when you see, there was a very low traffic density, right? Only one call will be there for in one radio channel, and the voice quality is also not so good, and it is not encrypted too. So there, what will happen means anyone can interrupt that call, and they can make a call inside that, and some cross calls, cross talks, and all was also there, right? This is a unencrypted transmission, and so this led to spoofing of its identity, right? This is in 1G, that is first generation. In the year 1981, NMT launched. NMT is Nordic Mobile Telephone Communication, right? And the next one is 2G, that is second generation, in the year 1991. This is GSM launch. GSM means Global System for Mobile Communication, right? In the second generation of mobile systems, this were placed on digital transmission with GSM, right? GSM is Global System for Mobile Communication, and this is a popular standard which is used in this second generation. Here they have used 19 megahertz and 1800 megahertz for the frequency bands, right? And in this GSM, that is Global System for Mobile Communication System, this has grown digital transmission using SIM, right? SIM means SIM, that stands for Subscriber Identity Module, right? This SIM technology to authenticate a user for identification and for the payment purposes also, right? This will help you to encrypt the data to prevent uh, others from accessing your own call, right? And for this encryption purpose and all, they introduced a term known as SIM, and that is Subscriber Identity Module, right? Here the transmission used is TDMA, okay? In the book they have given us TMDA, just strike it out and write it. TDMA is the correct one, right? This TDMA stands for time division multiple access, and CDMA is code division multiple access, right? This method is used to increase the amount of information which has to be transported on this network, right? Mobility is supported at layer 2, which stops when the roaming occurs, right? When this roaming across the assorted access networks and this routing domain, that means when you are in this Kanyakumari district itself, when you go and cross that Kaliyakavala or that Kerala zone, when you enter the Kerala zone, it's this area, this operator will be changed to the next network, right? So this must cover the entire area or have agreements in place to permit that roaming, right? So here layer mobility is supported at layer 2, which stops that roaming across assorted accessing networks and this routing domains also, right? This all in 2G, okay? 2G is second generation in the year 1991, and this is GSM launch, right? And the next one is second to third generation bridge, that is 2.5G. The second generation we'll say it is 2G, and third generation we are saying it as 3G, right? And this one is second to third generation bridge, that is 2.5G, right? And this in the year 2000, and this is Gprs launch, right? Gprs, this Gprs we would have heard, most of the places you would have heard, right? Gprs is General Packet Radio Service, right? This Gprs was introduced here in this 2 and 3 bridge, right? Between this 2G and 3G, it was second to third generation bridge, that is 2.5G, right? And this is the excess period of mobile networking development between this 2G and 3G, right? The GPRS means it is a data service which enables the mobile data to send and receive the messages, right? And for picture messages, for emails also. This allows most popular operating system of up to 115 kbits per second, right? Laterally maximum of 384 kbits per second using this edge, right? Edge means enhanced data rates for global evolution. Edge, the word edge means enhanced data rates for global evolution, right? GSM data transfer rates typically reached 9.6 kbits per second, right? And here they have used the edges enhanced data rate for global evolution, right? And next one is 3G, that is third generation. This is introduced in the year 2003, and first UK 3G launch, right? This generation of this mobile network means this merges different mobile technology standards. That means it uses a higher frequency bands for many transmission, right? For many transmission, and that CDMA also. CDMA is code division multiple access, right? This is done to deliver the data rates of up to 2 bits, right? 2 bits here is 2 megabits per second, right? This supports the multimedia services also, like voice, video, and other data transfers also. Now you have seen MMS, right? Now we are sending SMS in smartphones and all. MMS is also there. That is, you can send a picture or a video or some data also through this mobile, right? Next one is European standard is UMTS. UMTS is Universal Mobile Telecommunication Systems. Okay, this mobile phone system continue to use the digital transmission of this SIM authentication for the billing process, and also for this data encryption also, right? So this data transmission used here WCDMA, right? This wide band code division multiple access. There we saw CDMA, that is code division multiple access, and here it is wide band code division multiple access, right? WCDMA. This technique is used to obtain the rates between 384 kilobits per second to 2048 kilobits per second, right? Few 3G suppliers use ATM, that is asynchronous transfer mode for over the air network, right? With this MPLS, that is multi protocol label switching or IP for their network, right? For the main one used is IP, and for the over the air, for that ATM, that is asynchronous transfer mode, here they use MPLS, that is multi protocol label switching, right? Mobility is still supported at layer 2, and so here this 2G still prohibits seamless roaming beyond this heterogeneous access networks and routing domains. That means here not only in the routing domain, but also in accessing each network, this 2G had some this roaming problems and all were there in this 2G, right? The transmission were band frequencies between 1900 to 2200 megahertz, right? This frequency bands and all will be notified in hertz only. Here the frequency band is between 1900 to 2200 megabits, right? In UK, if you see, all the UMTS license holders will hold a 20-year license with the condition that 80% of the population coverage will be achieved by 31st of December in the year 2007. Present third generation licensed operators in UK are also shown here. That is at August 2004, right? Next one is fourth generation, that is 4G, right? 4G is the research stage. Okay, this was based on an ad hoc network model where it had no need for fixing any infrastructure operation and all. This ad hoc networks needs a global mobility features. That means like mobile IP and some connectivity to the global IPv6 network. This will support an IP address to each mobile device, right? Logically, if you see this roaming in assorted IP addresses, like if they are given an example here, 802.11 WLAN, Gprs and UMTS means this in this assorted IP address, some if there is some roaming, it can find it, right? Where possible with higher data rates from 2 megabits per second to 10 to 100 megabits per second. This offers a reduced delays and new services also, right? These mobile devices will not expect any fixed infrastructure here in this 4G, but they will require enhanced intelligence to self-configure that with which network here they have used ad hoc networks, right? So this ad hoc networks must enhance their intelligence and it has to self-configure themselves so that they are having a routing ability to route over a packet switching network itself, right? This is about fourth generation, that is 4G, which was launched in the year 2007, and the next one is 5G. 5G means after 2019 only we got this 5G or this fifth generation. This is the stage success or succeeded the 4G. In iPhones and all, if you see, they will be giving us LTE, or in some brands, they will be giving us WiMAX. And 3G, we say it as UMTS. 4G means LTE, okay? 2G means that is GSM systems, okay? 5G targets to perform the high data rate, reduce the latency, energy saving mode, and to reduce the cost. The system will be working with high power for high efficiency, capacity, and a massive device connectivity, right? The two phase of this 5G is first one will be released 15 completed by March 2019, right? That was completed in the year 2019 in the May of March, and the second one, release 16, is expected to complete at March 2020. This book was printed before March 2020, right? So this it was expected like that they have given here. So this is um, released 16, that is second one released in 16 is in March 2020 for the submission to ITU. ITU is International Telecommunication Union as a candidate of this IMT 2020 technology, right? ITU is International Telecommunication Union IMT 2020. This provides the speed up to 20 gigabits per second. 20 gigabits per second. So just think of the speed, how it will be. If you are downloading a movie, within 1 minute you can download a high quality movie, right? So this speed you will get when you are accessing this 5G, right? This is demonstrated with millimeter waves of 15 gigahertz and higher frequency. 3GPP standard includes any networks using this new radio software, right? 5G new radio, this can access at a lower frequency also from 600 megahertz to till 6 gigahertz also, right? 6 GHz also. Speed in this lower frequency are only modest higher than 4G systems. This is estimated that it will be 15% to 50% faster, right? That's all about this generations of mobile networks, right? First you have seen about first generation, that is 1G, that is in the year of 1981, that is NMT launch, right? 2G is 1991, that is GSM launch. GSM is nothing but global system for mobile communication, right? And the third one is 2.5G, that is second to third generation bridge. The next one is third generation 3G, that is in the year 2003, and then 4G in the year 2007, and 5G after 2019, right? And next we are going to see about WLAN's 802.11. Okay, this Wi-Fi. Wi-Fi, we all would have heard the name Wi-Fi. What is Wi-Fi? What is the full form of Wi-Fi? Wireless fidelity, right? Wireless fidelity. This is a wireless network technology which permits the computer or any other devices to be connected in the network without using the cables, right? This Wi-Fi is additionally stated as wireless local area network. For that only it stands for wireless local area network. That only here they have given us WLAN, right? Wireless local area network, that is WLAN. And 802.11, this is the technical code for the protocol, right? Let's see the advantage of this Wi-Fi. Okay, the benefits of this Wi-Fi are it provides mobility. Example, when I get the internet connection wireless through my laptop or a computer in the home, or at work, because of this Wi-Fi or hotspots both at home and work, it can be used, right? When you are having a net connection wirelessly, you can move it anywhere you want and you can use it, right? The next, that is mobility, right? The first advantage is mobility, and the next one is it provides the connection to internet. Next one is flexibility of LAN. Flexibility of LAN means the local area network is so flexible. Next one is ensures the connectivity. You can just check it whether it is connected or not in your device itself, right? Then it allows remote places to benefit from this connectivity. Some places you cannot take wire and all for that long. That places also this Wi-Fi can be used to get network, right? This is low cost and it has high benefits, right? This is about WLANs, that is Wi-Fi. Okay, Wi-Fi is wireless fidelity. Okay, and the next one we are going to see is RFID. RFID is a tag, that expansion of RFID is radio frequency identification, right? That RF stands for radio frequency and ID stands for identification. Okay, this technology is designed to locate the objects, right? This means credit cards, maybe passports, or even livestock using a radio signal. Okay, this RFID is used radio waves to read and capture the information which is stored on a tag attached to the object, right? When there is an object, it will have a tag with this RFID, right? RFID tag will be there in the object. When you just read it from, you don't need to just go near that. You can be some feet away from that and it can just read the tag and the details of that object or that RFID reader. That RFID means it will have two parts. One will have a tag and another one side is a reader. That reader, if that reader is installed in your computer, RFID tags are installed with the transmitter and receiver, right? One RFID tag will be there in the object, means the reader can read it, right? This RFID component on the tags has two parts. One is microchip which stores the process of information and another one is antenna which is used to receive or transmit the signal, right? The tag will reply the information from its memory bank and the reader will transmit to the result side, right? It may be to the computer program. RFID program will be there, no there, right? Two types of RFID tags were there. One is active RFID, another one is passive RFID, right? Active RFID means what? Passive RFID means what? In a passive RFID tag, the power is supplied by the reader when this radio waves from the reader are reaching the passive RFID tag, right? The coiled antenna forms the magnetic field and this uh, RFID tag itself will provide the power to the is provided by the reader, right? The next one is battery powered RFID tag. This is installed with small battery and that powers the broadcast of this information, right? The main components of this RFID system are RFID tag. This is a silicon microchip which is attached to a small antenna and mounted on the substrate, right? What is the in the object? This RFID tag will be placed, right? And next one is reader. Reader means RFID will have a reader. This has a scanner with antennas to transmit and receive the signals which is used for communication, right? When you read this, when you have a scanner only, you can scan and read the RFID tag, right? And the next one is a controller. Controller means it is a host computer with a microprocessor which receives the reader input and it has to process the data, right? That is the controller. The two types of RFID tag we saw, that is active RFID and passive RFID, right? Active RFID means the tag has its own power source. That means this system will be used for large distance to track vehicles, high value goods for some big valued products, right? Passive RFID means this tag gets the power from the reader antenna to tag antenna, right? This is used for a shorter range transmission. If it is a large distance and if has to reach a long distance means we'll use this active RFID system. And if it is a short range of transmission means here we'll use passive RFID system, right? And next one is reference model, that is OSI model. OSI means Open System Interconnection. Okay, this model is found in the year 1934. Right, generally this frameworks will enable network protocols along with the software, and the systems will be developed based on the general set of rules. Some rules will be there, in that according to the rules the software will be developed, right? This describes the standard for the intercomputer communication. That means the communication between the computers itself, right? There are many prompts used to remember here. They have given a tips in your book, that is everyone needs data processing. Everyone should try new diet Pepsi, like that, right? This is the OSI layer order. That means this OSI layer means it has physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer, right? These are the OSI layers, right? We'll see the explanation of this OSI layers in the next session, right? Now let's have a recall of what we studied in this session. Okay, we have seen about RFID tags, right? RFID tags, we have seen the components. It had a tag, reader and a controller. We have seen two types of RFID systems, active RFID systems and passive RFID systems, and we have seen about WLAN's 802.11, that is Wi-Fi, that is wireless fidelity, right? And the advantages about that. And we have seen about the generations of mobile network, that is 1G, 2G, 3G, 2.5G and 5G, right? 4G also. That is first generation, second to third generation bridge, third generation, fourth generation and fifth generation. We have seen about the generations of mobile networks also in this chapter, right? You just take your book and read these generations and about this WLANs and this RFID tags, and underline the key points also, so that it will be useful for you when you are learning for the final exam. And about this OSI layer, we'll see in the next session. Okay. Thank you for your valuable time. Stay home, stay safe. Take care. Bye.